All right, hello everyone. I hope you are excited about your Unit 7 test on circles. Okay, some tips for studying. Try this packet all by yourself first. Okay, leave blank what you don't know. Go back to your notes, try and figure that out. Then, if there's still some stuff that you're confused about, or you just want to hear a teacher talk through, come back to this video. Like and subscribe. I'm trying to get more views than Miss Cass this time, okay? I know the quality is not good, but you got this packet from your teacher too. Anyway, okay, here we go. Circles. The measure of the arc from B to A, but not passing through C, is 30 degrees. So from B to A. We could also have B to A this way, but they said not passing through C. So B to A here, measure of that arc is 30 degrees. When we say the measure of the arc, that is the angle. Arc length is the actual length of that segment. Okay, so this measurement is 30 degrees, and they're asking me for the measure of BOA. So BOA. That is a central angle, right? Because the vertex of the angle is at the center. Central angles are equal to the arc lengths. So this one, 30 degrees. Okay, but then the measure of these other two angles, BDA and BCA, those are inscribed angles. So as long as these two endpoints of my angle are the same, it doesn't matter where that vertex is, C or D. The inscribed angle is half the measure of the central angle. So half of 30 would be 15. Be sure you're using degree markings because now we've learned about radians, right? So if you just say 30, I'm gonna be like 30 what? 30 radians? 30 degrees. Maybe I zoom. I don't know if that's worse or better. Okay, find the measures of these angles. CFE. CFE. Ask me about this one. Okay. And also DEF. So these two angles. Think back. What did we learn about for four-sided shapes, quadrilaterals, that are inscribed in a circle? Yeah, those alternate angles add up, or the opposite angles add up to 180. Okay, so to find CFE, the opposite angle is 123. So I'm just going to take 180 minus 123. Got my handy dandy calculator. Gives me 57 degrees. Okay, DEF is the same. So across from this angle is 95 degrees. So 180 minus 95 gives me 85 degrees. Again, don't forget your degrees. Don't forget, don't forget. Okay? Now they're asking about the arc from C to E passing through F. So C to E, but going through F. And here we are. So think about this. What angle would be helpful here? Okay, I see those endpoints are C and E. Okay, hey, I also see that this angle here has endpoints C and E. Okay, so angle CDE is inscribed, an inscribed angle. Okay, like we just talked about up here, inscribed angles are half of the central angle, and the central angle is equal to the arc. Okay, so if this is half the central angle, to find what the central angle is, we need to double it. Okay, inscribed angle is half of the central angle, so the central angle is double the inscribed angle. If you have no idea what I'm talking about, you need to brush up on your vocab. Okay, so 123 times 2. 246 degrees. Don't forget degrees. Okay, the arc from D to F passing through E. So from D to F passing through E. All right, again, look at those endpoints. This is definitely connected to this angle C. Okay, so 95 times 2. 95 is the inscribed angle, so the central angle and the arc are double that length, so 190 degrees. All right. What is the measure of angle X, Y, YXZ? I can't read. YXZ. So they're asking me about that one right there. Okay. YXZ. This line is tangent to the circle. So a line being tangent to the circle means two things. Number one, it means it's intersecting the circle at only one point, exactly one point. Number two, it means that it's making a 90-degree angle with the radius. The tangent line is perpendicular to the radius, okay? So how can I find this missing angle measure? Well, the angles of a triangle add up to 180. So 180 minus 52 minus that 90 degrees I know from my tangent line. Gives me 38 degrees. Okay, I know some people do it a slightly different way, where they take 52 plus 90. Oops. And get 142, and then they take 180. Whoa, that's not even a number, you guys. Minus 142. That would also give you 38. Okay, so either way, the angles of a triangle add up to 180, and tangent line is perpendicular to the radius. All right. Find the area of a sector of a circle. So that's like our slice, our pizza slice, with a radius of 6 centimeters. Don't forget your units. And a central angle of 4 pi over 3 radians. All right. So the area of a whole circle is pi r squared, but this is just part of the circle. So what you got to think about is, okay, part out of the whole circle. How many radians is the whole circle? In degrees, a whole circle is 360. What about in radians? 2 pi. Okay. So to find the area of this sector, I'm going to take the part, 4 pi over 3, out of the whole, 2 pi. This is the part I'm looking at. The whole circle is 2 pi radians. Then I got times pi r squared. Radius is 6. So pi 6 squared. Okay. Now I want to simplify just this fraction here. There's a couple different ways to do it. You can see that dividing by 2 pi is the same as multiplying by 1 over 2 pi, if you think about it that way. In my class, we've been doing keep, change, flip a lot, okay? So if you have a fraction in a fraction, here's what you do. You keep the first one the same, so 4 pi over 3. Change this division to multiplication, and flip whatever's on the bottom. So this 2 pi is actually 2 pi over 1. So I'm going to flip that and have 1 over 2 pi. And this stuff tags along too, times pi times 6 squared. Okay. Hey, I see pi divided by pi. All right. Then we're going to multiply all the numbers together without pi. I want to leave my answer in terms of pi, so type in all your numbers, and we'll just put pi right back on at the end. Okay, so let me show you what I'm typing in my calculator. Oops. Okay, 4/3. So 4 divided by 3 times 1 over 2, right? Times 1 divided by 2 times 6 squared. 24. So all those numbers became 24, and pi is still hanging out. Don't forget your units. This is area. Area is in units squared. Think of the area of your house in square footage, okay? Also, I remember because this is r squared. So whatever your units, squared. I know some of the other teachers might show simplifying these kind of things a little different, but whatever way you do to get down to 24 pi, go for it. Okay. Here's a circle. Here is a circle with a shaded sector. Okay. They want me to find the area. Hey, we just did that. Just we didn't have a picture. Okay. But now I'm in degrees, right? So think about this. So the area, I need the part out of the whole. So the part I'm looking at is 60 degrees. a whole circle is 360. Okay, times pi r squared. My radius is 30. Okay, maybe you've seen a formula that looks like this or something. Right, that's the formula I'm using. This is theta, it's a Greek letter, always represents an angle measure, okay? So again, this is in feet, so don't forget about our units. Maybe I'll even circle it to remind myself. Type in just the numbers, just the numbers. So 60 divided by 360 times 30 squared. Oh, I double squared it. Oh. My students know this, but whenever I say check, or whenever we take tests and stuff, I always say check your work. That's what I mean. Like, whoa, did that number make sense? You should be checking like as you go. Okay, 150 pi. Units. This is feet, so feet squared for area. Area is in units squared. Okay, find the length of the arc defined by the sector. Okay, this is different than what we were doing on the front page when it says the measure of the arc. I know it's confusing. The measure of the arc is in degrees or radians, okay, an angle. The length of the arc is literally like length on a ruler, like how big is it? So the length of the arc, okay, our circumference is 2 pi r. So the same idea here, I need to just take part of the whole, okay? So for the arc length, I'm just going to take that 60 out of 130, or 360. 130, what am I talking about? Okay, part out of whole, 60 out of the whole 360 times 2 pi, my radius is 30. Again, typing in just the numbers, 60 divided by 360. Okay, pi is a number. You guys know what I mean. 10 pi. And length is just feet. Just feet. Okay, so you could tell because r is not squared, so it's just feet. Also think about, I don't know, a ruler. Y'all ever looked at a ruler before? It's in inches, not inches squared. Okay. All right, a sector of a circle. So again, this is what a sector is. That's our pizza slice. So a sector of a circle has a central angle of 210 degrees. Again, this is my central angle. And arc length of 28 pi. And they're saying, what is that radius? So my final answer, every time I see what is blah, 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 I'm like, okay, my final answer should look like r equals. Okay? So let's think about this. They're giving me an angle and an arc length. Hey, look up here. This was an angle and it gave me arc length. I've been using S with my students. Don't ask me why. Don't know. We've also been using L. Okay. So maybe I'll use L for this one. I don't know. No, I'll just use S. Sometimes I don't know why they pick these letters. I'm not gonna lie. Okay. So part out of the whole, 2 pi r. All right. Here is my arc length formula. I'm going to plug in what I know and solve for what I don't. I do not know r, so is my cursor on this the whole time? Anyway, I do not know r, so it's going to stay as r. The angle is 210, so I'm going to plug in 210. Again, r is going to stay. Arc length is 28 pi. 28 pi. You see that? It's different than before. Before I knew the radius, so I plugged in the radius. Now I don't know the radius, so I'm leaving it as r, but I'm plugging in that I know the arc length. Plug in what you know and solve for what you don't. That's like pretty much all the math, okay? So these can be a little tough, not gonna lie, but you can do it. You're so smart. Okay, first I want to get rid of this pi. It's kind of bugging me. If I divide by pi on both sides, because it's being multiplied here, right? Opposite multiplying is dividing. Hey, look, goes away. That's convenient. Now I just have 28 equals 210 over 360 times 2r. Your teachers might have given you different methods to handle this, okay? Use your algebra solving skills, okay? I'm trying to get r all by itself, see? Like that. To get rid of this fraction, you can multiply by the reciprocal. Now, what do I mean by that? Let me show you. I'm dividing by 360. So to undo dividing by 360, I want to multiply by 360. To undo dividing by 360, I want to multiply by 360. To undo multiplying by 210, I want to divide by 210. So you see that, how I had this really ugly fraction, and I just multiplied by the reciprocal, flipped it over. But this is algebra. Whatever I do to one side, I have to do to the other. Guess I can't say this is algebra because this is geometry. I usually only teach algebra. It's my first year teaching geometry, guys. How am I doing? Okay. So on this side, look what's happening now. I have 360 on top and bottom, 210 on top and bottom. Bye-bye. So the only thing left on this right-hand side is 2r. This, you can just type in your calculator. Look, that's all numbers. That's all numbers. So 360 divided by 210 times 28, 48. 48 equals 2r. Am I at r equals yet? No. Got to divide by 2. This is 2 times r. We're going to divide by 2. So 48 divided by 2 is 24. The radius is 24. Okay, there was an example or a question on your third check-in where you had to go through something like this, but then at the end, they said, what is the area of the whole circle? Okay, so if you're finding radius as part of the process to finding something else, right? Like you need radius to find the area. So if you're solving for radius, don't forget to find what they're asking for. So this one they said, what is the radius? So my final answer should be r equals. That one on your check-in, I think it was number 2, said, what is the area? So you should be sure you have a equals. Okay, finding the radius was part, but you've got to be sure you find what they're asking for. Let's talk about some facts about the circumcenter, okay? Because that's where the circumscribed circle comes from, okay? So your circumcenter is constructed from your perpendicular bisectors. Don't come for me if anything's spelled wrong. I don't know how to spell, okay? Constructed from your perpendicular bisectors, and it is equidistant to the vertices. Okay, that is what is creating the circle, and you guys will see what I mean in a second. Okay, so just some facts about circumcenter. While we're here, let's review incenter. And I'm probably going to end up writing over all this anyway, because I got to use my compass. Okay, incenter comes from angle bisectors, and it is equidistant to the sides of the triangle. Okay, so there you go. Just some little recap. Every time you see one of these two words or any of these things, you should link all these 3 things together. This is your circumcenter. These are facts about it. That's your incenter. These are facts about it. Okay, construct the circumscribed circle. Place the pointy end on your compass on one of the vertices. This doesn't have to go all the way over. It can go just over halfway, as long as it's over halfway, okay? And make an arc. See how good I do. This compass is not the best. Oh, now there's going to be video evidence. Okay, there's my arc. Keep the same width in your compass. The pointy end there. And do your arc that way. Or this is hard for me because I write left-handed. I can't tell if I'm supposed to use my compass in my left hand. I don't know. I need a straight edge. Guys, I don't have anything. I'm just gonna use another piece of paper, okay? These arcs need to connect in two places. Do you see that? This shape I've created from here to here. Those 2 points are what I'm gonna line up with my straight edge. Don't worry about what this paper is, it's algebra 2. You'll learn next year. Okay. Line up with my straight edge. There you go. Yours will be nicer because you'll have a ruler. Okay. Now I have to do this on another side. So you get to pick whichever one you want. I think I kind of want to do this one. Okay. I'm going to orient this to work for me. Again, pointy part on the vertex. This only has to go like halfway, at least halfway. Oh, shoot. Because I goofed. Okay, there's one. Oh, no. There you go. Okay, I had some little goofs there, but I did get a nice curve eventually. Okay, so again, look at, you need 2 places where they intersect. Okay, it's not enough to just, I had some people on their check-in just doing that part. No, you need 2 so you can connect the 2 points with a line. That is how you construct a perpendicular bisector. Okay. Don't tell. Sorry to whoever's going to use that. It's got pen on it now. Okay. This point where the 2 lines intersect is the circumcenter, the center of your circumscribed circle. Okay, marked it in red. So that means this center must be equidistant to each vertex. And I'm checking. Yeah, looks pretty good. So put your pointy end on that center and the pencil end on the vertex. Okay. And when you go to make your circle, I'm going to do one of these. Classic. It's pretty good. It should go through all your vertices. Okay. Do not erase your construction lines. I know you probably don't have a compass line around at home. I don't. Okay. But if you're watching this video, go and practice in class, okay? Be like, hey, can I have a compass, please? I need to practice. Cool? And again, be sure you're reading. They said construct the circumscribed circle. So I'm looking for that circle that's going around the outside. Finding the circumcenter is just part of it. They're asking for the circle itself. All right. Next page. A circle has radius of 16 units and a central angle that defines an arc with a length 4 pi. So that's our L. That's our L. A second circle has radius 5 units and central angle theta defines an arc with length 5 pi. You see how I'm writing up here? Your test should look like this. I'm not doing this for fun. This is helping me. Okay. Our definition of radians for my angle is arc length divided by radius. Arc length divided by radius. Okay, that is the formula that is relating those 3 letters together. Radius, length, and central angle. Okay, so how do these compare? Be sure to explain or show your reasoning. Okay, I'm just going to split this in half so I can do one and then the other. So the first one, central angle is 4 pi over 16. Keep these in fractions. Let's practice simplifying fractions in your calculator. My students, you should all have this written down. If not, I'm going to get you. Okay. Type in your 4 divided by 16. Okay. Maybe you see this is 0.25 and you're like, Miss B, I know that's 1/4. Okay. If not, you can hit second and then this PRB button and enter. 1/4. So this would be 1 pi over 4, which is just pi over 4. Okay, that's the first one. The second one has a radius of 5 units and an arc length of 5 pi. Okay, so my arc length on top, 5 pi, divided by the radius, 5. Hey, I know what 5 divided by 5 is. That's 1. So it'll go away. That's 1. This is just pi. What? So how do the measures of those two angles compare? This one's way bigger, right? Pi instead of a quarter of pi, pi over 4. Okay, so how do they compare? The second angle. Oh, don't look at my handwriting. Is bigger. Whoa, do not look at my handwriting, guys. If you are not my student, count yourself lucky that you don't have to look at my handwriting every day. If you are my student, I don't want to hear nothing. Right, second angle is bigger. Circle B is a dilation of circle A. All circles are similar. Fun fact. Okay, what is the scale factor of the dilation? Okay, so I had 3 and now I have 9. Looks like I multiplied by 3 to get there. K equals 3. What is the length of the highlighted arc here? Okay, I don't know if you can see it because my camera is really bad. What is the length of this arc? Okay, and they're going to ask me the same thing here. All right, well, I know circumference is 2 pi r, and this is a quarter of my circle, right? 90 degrees, quarter of the circle. So the length of the highlighted arc, you can do 90 divided by 360 times 2 pi r. Radius is 3. Or if you're like, Miss B, I know that's 1/4 of the circle. Spoiler alert, 90 divided by 360 is 1/4. Okay, so type this in. Don't type in pi. We'll just put pi on at the end. 90 divided by 360 times 2 times 3. 1.5. 1.5 pi. And we can just write units. Units. They didn't tell me what the units are. So then what is the length of the highlighted arc here? Well, I could go through all this again, but I'm being scaled up by 3. Dilation with a scale factor of 3. So I can just multiply this by 3. Right? It's 1.5 times 3. Oh, 4.5. 4.5 pi. Okay, and if you were to type in 90 out of 360 times 2 pi 9, you would get that. Yeah, if you don't believe me. There it is. Okay, what is the ratio of the arc lengths? Okay, ratio of the arc lengths is 3/1, right? 3/1. Or 9/3, I guess. Hold on, you guys. 9/3, which simplifies to 3/1. There we go. I said it right eventually. Okay, so how does this ratio compare to the scale factor? Hey, it's kind of what I just mentioned. I kind of skipped ahead a little bit. I hope you don't mind. I spoiled it. The ratio is equal to the scale factor. Do not write it's equal. It's the same. What is it? What is it? I don't go around calling you it. I use your name. The ratio is equal to the scale factor. not they are equal. It is equal. Tell me what it is. Last one. Identify the type of center. Then find the measure of CD. Okay, so this is my ultimate goal. And then they're giving me some formulas for AD and DB. Okay. Let's look back at our list we had earlier, okay? The circumcenter is from angle bisectors, and that means the distance to the vertices are equal, okay? If I have, did I say perpendicular bisectors? What did I say? I don't remember, okay? If I have angle bisectors, they're equidistant to the sides, okay? Those are our two measures of center for a triangle. So what's happening here? Look at our congruency markings. Are the sides being bisected or the angles being bisected? Look how high up I can raise my eyebrow. Yeah, the sides are being bisected. So these are perpendicular bisectors, meaning this is a circumcenter, meaning it is equidistant to the vertices. So these dashed lines are all the same length. Okay? We'll talk through that again. These are perpendicular bisectors, meaning this is a circumcenter, meaning it's equidistant to the vertices. If you have one of these things, you have them all. Okay? The one on your check-in number 2 was an incenter. So go back and review that one for another example. Okay, so these are all equal to each other, right? And they're telling me that this length is 2x plus 7. This length is negative x plus 4. Well, hey, I just said that those lengths are equal to each other. So if these are the same length, then these two expressions have to equal each other. If those are the same length, then those expressions are equal. Equal length, equal expression. So here's what I'm going to do. 2x plus 7 equals negative x plus 4. If these are equal to each other, then these are equal to each other. Right? Okay, now I just need to solve. I'm going to add x here. Okay, so now I'm just left with 4 on this side, and now I have 3x plus 7. All right, trying to get x by itself, so I'm going to subtract 7 on both sides. I have 3x equals negative 3, right? 4 minus 7 is negative 3. This is 3 times x, so I'm going to divide by 3. X is negative 1. Is that what they were asking me to find? Did they say find x? Am I done? No, I'm not done. I need to find the measure of CD. So how am I going to do that? Well, CD is equal to this measurement, and it's equal to this measurement. Oh, if only I had some information about how long segment AD is. Oh, it's right there? Oh, and now I know what x is? What? I'm going to plug x in. What is happening? Oh, I got a weird notification on my computer. So these are equal lengths. So that means you can use this formula to find the length of CD, okay? Because AD and CD are the same length. So that means that CD can be 2x plus 7 also. Okay, and hey, I know what x is. X is negative 1. So CD, 2 times negative 1 plus 7. Whoa, my handwriting is getting really bad. So negative 2 plus 7, the length of segment CD is 5. Okay, I did those solving kind of quick because that's our algebra skills. The logic of setting these two equal to each other and then plugging x back in to get that side length. That is the geometry part. Okay, so this has a length of 5. Actually, these all have a length of 5. They were just giving me all this like weird information instead of just saying 5. How we feel? Feel good? Feel better than when the video started? Okay, good luck studying for your test. Your test is Wednesday, the 30th. And I will see you guys then. Half day on Tuesday, so don't think you're getting 2 full days of review, okay? Okay, study, do your homework, do your check and corrections, study, 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 do some math. Bye.